Okay, so if we do the same thing for 1cx cubed plus 4x, we're going to factor that to find our zeros. So this is like equals 0. First thing I'm going to do is we're going to factor out an x. So we get x times x squared plus 4 equals 0, which then tells me either x equals 0 or x squared plus 4 equals 0. Okay, so I know that my first answer is 0. I know that I need to have 3 of them because I have an exponent of 3. So if I solve this for x, I subtract 4, bless you. So I get x squared equals negative 4. So then to get rid of my squared, I take the square root. So I get x equals the square root of negative 4, positive or negative. But since we learned yesterday, we can simplify the square root of negative 4 by making it the square root of 4 times the square root of negative 1. We know that the square root of 4 is 2. We know that the square root of negative 1 is I. So we get x is equal to positive or negative 2i. So those are my other two solutions. Okay, so let's do one more. So we get x to the 4th minus 1. Okay, well if I factor this, I would get x squared plus 1 and x squared minus 1. That's how you factor a 4th root equals 0. Start with that. We start by factoring out the x to the 4th into 2x squareds and the 1 into positive 1 and negative 1. Okay, then we know that x squared plus 1 equals 0 and x squared minus 1 equals 0. Then if we solve those for x, first thing we do is subtract 1, subtract 1. So I get x squared equals negative 1. Then over here, if I add 1 and add 1, I get x squared equals positive 1. So then to get rid of my squares, I take the square root. So then I get x equals positive or negative square root of negative 1. And x equals positive or negative 1. Because the square root of 1 is 1. Okay, so I know 2 of my solutions are right here. And I know I had to get 4 because my exponent was 4. The other 2 come from this positive or negative square root of negative 1. The square root of negative 1 is I, so I get positive or negative I as my other 2. Okay, so this one has 2 real roots at positive 1 and negative 1, and 2 imaginary roots at positive I and negative I. Okay, so the next thing we're going to look at is our rational zero test. To figure out whether or not your polynomial has rational zeros, we take p over q. And p is a factor of your constant term, meaning your last term in your function. And q is a factor of your leading coefficient. Okay, so your first number in your function. Okay, so let's look at example 2 and let's figure out if we have rational zeros. Okay, so to solve our rational zeros, our rational zero test told us to take p over q, where p was your last term and your constant term, and q was your coefficient of your first term. And in this case, our coefficient is 1. Okay, so if I plug in p, then I get 1. If I plug in q, then I also get 1. And I know that, yep, 1 divided by 1 is 1. So then I would, yes, have rational coefficients because this ended up being a rational number. Okay, so we do the same thing for example 3. I have x to the 4th minus x cubed plus x squared minus 3x minus 6. And I need to figure out if I have rational zeros. Okay, so I know I'm going to take P over Q, where P is going to be my last term. Q is going to be the coefficient of my first term. So in this case, it's also, again, a 1. So P is negative 6. Q is 1. And negative 6 divided by 1 gives me negative 6, which is indeed a rational number. So again, yes, I have rational coefficients. Okay. The last thing we're going to look at is our Descartes rule to figure out the number of positive and negative, the number of zeros that we actually have. Okay, so the number of positive real zeros is equal to the number or less than by an even number the number of sign changes. Okay, and we'll look at what that means in a second. The number of negative real zeros is equal to or less than by an even number the number of sign changes of f of negative x. Okay, so when we're looking for our positive real zeros, we're using f of x. When we're looking for our negative real zeros, we're using f of negative x. Okay, so let's look at actually using that. So the thing that we're looking for in both situations is our number of sign changes. Okay, so I'm going to start by just labeling my signs of each section, each unit of this. So if I start with 3x, I get 3x cubed is going to be positive. Okay, then if I move on to my 5x squared, my next term, then I get, that's going to be negative. If I look at my 6x, that's positive. And if I look at my 4, that's negative. So then I need to look at when they change, okay? So obviously here's my first sign change from positive to negative. Then I go from negative to positive, so that becomes number 2. And then back from positive to negative, so that's sign change number 3. Okay, and your rational numbers, your real positive zeros come from either the number of sign changes or the number of sign changes less of even number. So I know that for my positive zeros, I'm either going to have 3 positive zeros because I have 3 sign changes, or less that by an even number, so our first even number is 2, so then, or 1. We drop it by 1 even number. Okay, so I'm either going to have 3 positive real zeros or 1 positive real zero. Okay, that's what that tells me. You always have to drop it by an even number. So we take 3 and then we drop it by an even number. If it were like 5, we drop it again every time we subtract 2. But you stop once you're going to go negative. So if I took negative 1 minus 2, then I ended up getting negative 1. So we stopped at 1. But like if this had, let's say this had 7 sign changes, it was a really big number, then I would know that I either had 7 even roots or 5 even roots or 3. I just go down by 2 every time until I get to a negative. Okay. The next thing we're going to look at is finding how many negative roots we have. And to do that, we have to find f of negative x. Okay, so to find negative roots, we find f of negative x. So, if I plug in negative x for all of my x's, then I get 3 times negative x cubed minus 5 times negative x squared plus 6 times negative x minus 4. Okay, and then if I simplify, this becomes negative 3x cubed, because a negative cubed stays a negative. This negative squared becomes positive, so minus 5x squared. 6 times negative x becomes negative 6x. And then I still have my minus 4. So then if I look for my sign changes, this one's negative, this factor is negative, this factor is negative, and the last one's negative. So since they're all negative, I have 0 sign changes from the first one to the last one. Yeah.
So negative 5 and then x squared turns positive.
Oh, yeah.
This changes to a positive, but the negative out front stays.
Why?
Because this is like negative 5. And this is like negative 1 squared and x squared. Negative 1 squared becomes positive 1. And negative 5 times positive 1 stays negative 5. You end up having like 3 negatives there, and 3 negatives make a negative. Does that make sense? Yes? No? Maybe so? Okay, so since we have 0 sign changes, then our number of negative zeros is just 0. We have no negative zeros. So we're either going to end up with 3 positive or 1 positive, and we're going to have no negative. Okay, so let's draw that one like that, because I know they can be kind of, Descartes' rule with negatives can be specifically confusing. So if I look at f of x equals negative 2x cubed plus 5x squared minus x plus 8. My first term is negative. My second term is positive. My third term is negative. And my last term is positive. So then if I group my sign changes, I go from negative to positive once. I go from positive to negative 2, and then negative back to positive 3. So I end up having 3 sign changes, which tells me that my number of positive zeros is either 3, or I have to keep subtracting 2, so then 1, because it's always less by an even number. Okay, so then I end up with 3 or 1 positive zeros. So then if I go to figure out my negative zeros, I have to find f of negative x. To find f of negative x, I plug in a negative x, so I get negative 2 times negative x cubed plus 5 times negative x squared minus a negative x plus 8. Okay, well, negative x cubed stays negative x cubed, and negative 2 times a negative becomes positive 2x cubed. Okay, negative x squared becomes positive x squared, so I end up with 5x squared. And then the negative times the negative gives me a positive, so this becomes plus x plus 8. Okay, so far so good? Okay, so this is positive, this is positive, this is positive, this is positive. So again, for negative x, we have 0 sign changes from one to the other, which tells me then that my negative zeros are 0. We don't have any. So we either have 3 or 1 positive zeros again, and we have 0 negative zeros. Okay. And there was one other thing that I missed when we were going over P and Q, so we're going to go over that again. So remember that to figure out how many irrational zeros we have, we use P over Q. Okay. Where P is my factors, is my last term, and Q is my first term. And we can use that ratio to figure out what exactly our zeros are by finding their factors. Okay, so I know that if I put this as a ratio, I end up with 3 over 2. Okay, but the next thing I want to look at is my factors of 3 and 2. So my factors of 3 are 3 and 1. And my factors of 2 are 2 and 1. And they can be positive or negative on all of them. Okay, so I'm going to plug these in up here. So I know that I have positive or negative 3, positive or negative 1. And for 2, I have positive or negative 2, positive or negative 1. Okay, and we're just going to start grouping them. So I'm going to group positive and negative 3 first. So I end up with positive or negative 3 over 2 as being my first option for my zeros. Okay, then if I group 3 and 1, I end up with positive or negative. 3 divided by 1 is just 3, so I end up with 3 as my second options for my zeros. Okay, and these are just options. They're not necessarily the answers, okay, but these gives us our options. Okay, then if I keep grouping, if I group 1 and 2, then I end up with positive or negative 1 over 2 as my third set of options. And lastly, if I group 1 and 1, I end up with positive or negative. 1 divided by 1 is 1. Okay, so these are my options. And if we notice, we have 2, 4, 6, 8 different options for my zeros. And so that's not necessarily very helpful for us, but it does at least narrow it down from infinity to 8. Okay, so these are my possible options. Once you get to this point, it's going to ask you to find your zeros. That's when I want you to graph. Okay, in the book, it tells you to do synthetic division with each of these. So that would be 8 synthetic divisions. Nobody wants to do that, right? So we're just going to graph. Okay, well, let's go over how to find those one more time, just so that when you're asked to find them in your book and on your test, you know what you're doing. Okay, so we're again going to do P over Q, where P is your last number, and Q is your first number. So then if we do that, P is negative 12, and Q is negative 10. We can reduce that to be 6 over 5. But when we're actually trying to find our answers, we have to leave it. Okay? So I know that 12 gives me 1 and 12 are going to be my first sets of factors. I can also have 2 and 6, and I can have 3 and 4. Those are all options for my factors. As for 10, I can have 1 and 10, and 2 and 5. And each of these can be positive or negative. Okay. So then if we rewrite that out, I get positive or negative 1, positive or negative 2, positive or negative 3, positive or negative 4, positive or negative 6, and positive or negative 12 as my factors for 12. Then if I write out my factors for 10, I get positive or negative 1, positive or negative 2, positive or negative 5, and positive or negative 10 as my options. Then we have to start grouping. So I'm going to start by grouping all these terms with my first term. So if I group 1 and 1, then I would get positive or negative 1, because 1 divided by 1 is 1. If I group 2 and 1, they end up with positive or negative. 2 divided by 1 is 2. If I group 3 and 1, 3 divided by 1 is 3. If I group 4 and 1, 4 divided by 1 is 4. 6 and 1, 6 divided by 1 is 6. And lastly, 12 and 1, 12 divided by 1 is 12. That gives me my first set of groupings. Then I'm going to start grouping everything on top with my second term. So 1 divided by 2 is 1/2, so positive or negative 1/2. 2 divided by 2 is 1. We already have 1 as an option, so I don't have to rewrite it. 3 divided by 2 is 3/2, so positive or negative 3/2. 4 divided by 2 is 2, which we already have from my first set of groupings, so I don't have to rewrite it. 6 divided by 2 is 3, which we already have from my first set of groupings, so I don't have to rewrite it. And 12 divided by 2 is 6, which again, we already have from my first set of groupings, so I don't have to rewrite it. Moving on to my divided by 5 term, 1 divided by 5 is 1/5, so I get positive or negative 1/5. 2 divided by 5 is 2/5, so positive or negative 2/5. 3 divided by 5 is 3/5, so positive or negative 3/5. 4 divided by 5 is 4/5, so positive or negative 4/5. 6 divided by 5 is 6/5, so positive or negative 6/5. And lastly, 12 divided by 5 is 12/5, so positive or negative 12/5. Okay, the last term we have to group with is that 10. So 1 divided by 10 is positive or negative 1/10. 2 divided by 10 is 1/5, which we already have from my first set of groupings, so I don't have to rewrite it. 3 divided by 10 is 3/10, which we don't have, so I have to write it. 4 divided by 10 is 2/5, which we have from my last set. 6 divided by 10 is 3/5, which we have already. And 12 divided by 10 gives me 6/5, which we have right here. Okay, so these are all of your options for zeros on that one polynomial. And so if you had to do synthetic division with all of those, I think you end up with 32 total. You'd have to do synthetic division 32 times, which is why we don't want to do that. We want to just plug this equation up here into our graphing calculator and identify which of these 32 zeros is actually correct. Okay? So we do want to learn how to list them out, but we don't want to necessarily do synthetic division with them because it's not helpful when you have 32. So you'll just plug that into your graphing calculator. So you guys are going to work through 176, 9, 11, 14, 9 through 22, 29 through 30, and 87 through 93. Only do the odds on 87 through 93.